Hello, welcome to study our course called Native Architecture. In this lesson 38, we will study Kubernetes deployments. So deployment provides declarative updates for pods and replicate sets. So we can see this net. So you describe a desired state in a deployment, and the deployment controller changes the actual state to the desired state at a controlled rate. You can define deployments to create new replicate sets or to remove existing deployments and adopt all the resources with new deployments. And so we can, this slide, if we want to deploy an application, we can use the pod. Okay, we can use this command kubectl run to create the pod containing the containerized service. But we can take an example. If we had deployed a container such as the online ticket ticket ordering system, but the traffic is very huge. So we one or several container is not containers are not enough. So we should deploy many containers to meet our business needs. So we can use this deployment. In the deployment, we can specify the replicate set. Replicate set's purpose is to maintain a stable set of replicate pods running at any given time. As such, it is often used to guarantee the availability of a specified numbers of identical pods. So if you use the traditional pods, you should deploy many pods one by deploy many pods. But if you want to use the deployment, you just specify the replicate number to meet our pods number. So now we can take an example. So here we can do a test. We can use the kubectl run my engines to create our pods, and use another way we can use kubectl create deployment to deploy the application. So here first we just we use the kubectl run my engines and specify the image equals engines. So here the pod my engines is created. So we create the deployment with the image Tomcat. We use kubectl create deployment, and with this deployment name my Tomcat, and specify the image equals Tomcat with the 8.5.68 version. So here, now we can see that the deployment app my Tomcat is created. So we can use the kubectl get pods to show all the pods. So we can see here that my engines pod and is running, and also my Tomcat with a random string is also running. This pod is created by the deployment this is the port name. Okay, so now we can here if we use this. Okay. So we can here if we use if we use the kubeset, if we delete the port my tomcat, what will happen? Okay, we can see kubeset use this get ports. Okay, we can use watch equals n and kubeset here get. Yes, we can use this command. This will enter the use the execute kubeset get ports every 2 seconds. So now we use kubeset delete port to the deployment of the deployment my tomcat. So what we will see. So we can say that the tomcat. We can say that the tomcat is okay. We can see here. We can now my tomcat pod is running again with another new pod. So the tomcat the deployment the pod is created by the deployment. So it has the ability of self-healing. If we delete the tomcat pod, the deployment will create another my tomcat pod automatically. So we just delete my tomcat pod again. So we can here allow it terminating. It will terminating this pod and then we are recreating a new pod. So we can now the deployment has the ability of self-healing to maintain the desired state of the deployment controllers change the actual state to the desired state. Okay, so that's our example. So that's all. Thank you.